Hello Gems, welcome to another video of ACE series. So let me just brief you about ACE series if you are new to this channel. Okay, so ACE series is basically a series of videos in which we discuss previous year BITSAT questions. Okay, so in this video over here we are going to discuss previous year BITSAT questions from the chapter of laws of motion. Okay, so if you have missed the previous videos of ACE series, check out the description box below. Okay, so with that being said, let's begin for today. So as usual, let us begin our discussion with some easy peasy questions, and then we'll increase the level from easy to moderate and from moderate to more moderate questions. Okay, so usually you won't find difficult type of questions in your BITSAT paper. Okay, so let's discuss question 1. Now whenever you have a question over here, it is expected from you that you pause the video and give the question a humble try. Okay, so question 1, no more talks. So in question 1 you have a train which is moving with a speed of 100 meters per second. In that train, from that train you are going to drop a ball. The ball has a mass of 0.05 kgs. Okay, you are supposed to tell me what is the net force on that ball. Okay, so quite a easy question from BITSAT 2018. Okay, now just feel this: when you are going to drop the ball from the train, the only force acting on that ball is 1 due to gravity, right? You just leave it, the force acting on that ball is 1 due to gravity. It's the only force and it's pulling it down, right? If you can see, the train is moving with constant velocity, right? So it won't impart any force or acceleration to the ball. Okay, so the only force on the ball is the 1 due to gravity. And what is the force due to gravity? It is nothing but the weight, right? Mg in the downward direction. Excuse me. So just compute this, right? 0.05 into 10, which is 0.5. So that is your answer. Okay, such a simple question. Of course, this ball will leave with this velocity, but this velocity has nothing to do with the net force, right? Now that was just given to confuse you. Even if it was a different value, the answer would have been the same. Okay. Now question 2, Earth is a non-inertial frame. You have to give reason why is Earth a non-inertial frame. That is from 2008. Okay, so is it due to revolution around the sun? Yeah, seems correct, right? Let's read the other options. Don't mark that in a hurry. So let's read the other options too. So rotation about the axis. Okay, this is correct too. Now Newton's laws hold. Okay, Newton's laws does not hold. It's a non-inertial frame, so Newton's laws, no way Newton's laws are held. Okay, Newton's laws cannot be held since it's a non-inertial frame. Now some people might be shocked, Newton's laws are not held on Earth, then why are we applying them? We assume that Earth is inertial. We assume that Earth has an inertial frame. Okay, so that assumption is actually very good when it comes to problem solving and very wide range of our day-to-day real life applications. Okay, so we assume that. Okay, and but for a fact Earth is non-inertial frame. Okay, now actually the correct option is D, right? Both A and B are correct. If you see, both of them are prompting that Earth is accelerated, right? Earth is accelerated, so it will be a non-inertial frame. Both revolution and rotation are prompting that Earth is accelerated, so accelerated frame, so of course it is an non-inertial frame. Okay, so that was from 2008, quite an old question. Even this one is an old one, 2007. So you have a shell, okay, spherical shell maybe, which explodes. Okay, that shell explodes. Now which of the following is conserved? Okay, momentum will be conserved, right? Because if you see, the explosion of shell was due to internal forces. There was no external force involved, right? So external force was 0, momentum must be conserved. Okay, so let's read the other options. Kinetic energy of course will not be conserved. You can say it this way, that when the shell explodes, some amount of energy is converted into sound energy, some is converted into heat. Okay, so you can see that energy is changed into different form. Okay, so kinetic energy may not necessarily be conserved. Okay, so momentum is the only one that is conserved. Both cannot be conserved, neither no, momentum is conserved. Okay, so over to next set of questions. Question 4 and question 5 over here. Again, these two questions are very straightforward. Okay, So in question 4, you have a ball of mass m. You are going to throw it with a velocity v. That ball will strike a wall, okay, strike a wall in front of you and will rebound back. Okay, the term rebound was used in the question. So rebound simply means it will come back to you with the same speed, okay, or the velocity will be flipped by 180 degrees. Velocity is flipped by 180 degrees. Magnitude is not changed. Speed is same, just the direction is changed, okay, towards you, rebounds. Okay, now you are supposed to report the impulse. So as I said, very straightforward questions, right? Impulse is nothing but change in momentum, right, which will be final momentum minus initial momentum. Let's take this to be initial condition, this to be the final, this is the final, this is the initial condition. Okay, now we'll consider this direction to be positive and this to be negative. Okay, so in final momentum m into minus v, m into minus v, right? So minus mv minus this minus sign, initial momentum m into plus v, m into plus v. So m into plus v. So here minus mv, you get minus 2 mv. Now keep in mind that convention was something that we chose. We could have flipped it, right? We would have got plus 2 mv. Okay, so the question purely prompts you to just to report the magnitude of impulse. Okay, this sign just shows that the impulse will be in the negative direction. Okay, the change in momentum is in the negative direction. Okay, so purely you are supposed to just report the magnitude. Okay, we could have flipped our conventions. Okay, so you have to just report the magnitude, which is 2 mv. Okay, very simple question, straightforward. Okay, now let's come to question 5. In this question 5, you have a man with the gun. Okay, so that man is firing a bullet. The combined mass of that man along with that gun is 100 kgs. Okay, the man is firing a bullet. The bullet's mass is 100 grams. Now he will fire 10 shots, 10 such shots. Okay, each of the bullet will have 10 gram mass, and the velocity of each bullet while leaving will be 800 meters per second. Okay, the ground is smooth and you are supposed to report the recoil velocity. Okay, the man will go back with certain velocity. When he fires the bullet, the man along with the gun will go with some velocity in the backward direction, so you have to report that velocity. Okay, does that click you? What do we have to use? You can see that if we consider this as a system, okay, there is no external force, right? All the forces are internal. So you can say that initial momentum equals final momentum. Okay, so initially when the man did not fire any bullet, the initial momentum 0. Final momentum, now the man and the along with the gun is going with some velocity in the backward direction. So 100 their mass into some velocity v. Okay, plus we'll consider now 10 shots are fired. Remember that. So 10 such bullets. Okay, so 10 mv, 10 mv. Okay, 10 shots, 10 bullets are fired. So 10 into m, mass of the bullet, into velocity of the bullet. Now mass of the bullet, this is in grams, so be careful. So this is in kgs. Okay, and you have 800 over here. Okay, so this and this will get cancelled. You can see that v will be minus 800 upon minus 80 upon 100. Okay, so that will be minus 0.8 meters per second, right? So option D. And even if you see the options, only this one is minus. The velocity should be minus, right? Suppose if we consider this direction is positive, which they have considered while saying the speed of the bullet is 800 meters per second, they said it plus 800 meters per second. So that is positive. Of course, the velocity of men along with the gun should be negative. And if you just had to see the options, option D, right? Only negative option. Okay. So over to the next question. Question 6 and question 7 over here. Again, these are not that difficult. Okay, so I know you are eagerly waiting for the moderate ones, but let's just do it quickly. Okay, so in this question 6, you have a car moving. So with what maximum velocity? It's a curved path. Okay, it's a curved path. now it's not bent, it's a plain curved path. Okay, so the car is moving on that path. So with what maximum velocity should the car move so that it maintains the radius of 150 meters? Okay, so that it moves in this circle of radius 150 meters. The mu, or the coefficient of friction of that road, is 0.6. Okay, so this is actually a board level question, right? A direct application of formula, which is Vmax is nothing but mu rg, right? This formula you might know. This is something which they teach in school also, very basic formula. Okay, so just substitute, right? Mu is 0.6, r is 150, g is 10. Okay, 0.6 into 10 is 6, 6 into 15, 6 into 150, 6 into 15 is 90, and that 10, so 900. So that gives us 30 meters per second. Okay, C is the correct choice. So formula based question in 2013. Okay, now in question 7 you have a ice skater. Now by the word ice, the question wants to make it clear that there is no friction involved in the question. Okay, so the ice skater is moving around in a circle of radius 50 meters. He is moving with a velocity of 10 meters per second. Now of course he has to make lean, right? He has to lean with respect to the vertical. He has to make certain angle with this is the vertical. He has to make some angle with respect to the vertical so that he moves in the circular motion, right? So what is that angle? What is that theta? That is the question above. Okay, so now you just have to draw the free body diagram of the skater. So now mg in the downward direction, right? He is leaning, so normal reaction in this direction. This is the vertical. Now he's making an angle theta with respect to vertical. Okay, now you can just resolve this, right? Just resolve it. So here you'll have n sine theta and n cos theta. Adjacent to theta, n cos theta. Opposite to theta will be n sine theta. You can see that under equilibrium n cos theta should be equal to mg, right? And n sine theta should provide, what should it provide? N sine theta should provide the centripetal force, right? So which is mv square by r. The n sine theta is towards the center, you can see that. So it is providing the necessary centripetal force so that the skater goes in the circle, around the circle. Okay, now there is no friction, so a component of that n, your normal reaction, is providing the centripetal force. Okay, so you have to find that theta. Okay, so what we'll do, we'll divide this. Okay, sine theta by cos theta, that will give us tan theta, right? I just divided second one by the first one. So n gets cancelled. Sin theta by cos theta is tan theta, mv square by r upon mg. So m and m will get cancelled and you'll have v square by gr. Okay, so v square velocity is 10 into 10, g is also 10, r is 50. Okay, so this gets cancelled. You can see that it's 10 inverse 1 by 5. 10 inverse 1 by 5. Okay, so basic drawing of free body diagram and solving the question. Okay, not that difficult, right? So let's move to the next set of questions. Question 8 and question 9 over here, again not that difficult, based on the concept of pseudo force now. Okay, so you, in question 8 you have an inclined plane with angle of inclination theta. It is accelerated now. Okay, the inclined plane is accelerated. On that you have a block of mass small m. Okay, so you have to find a relation between g and a when this block is at rest. Okay, this block is in equilibrium. Okay, you have to find a relation between g and a. Okay, let's do that now. So all we have to do is first dive into that frame, non-inertial frame, apply pseudo force, and then FBD, free body diagram. Okay, so let's dive into this frame. So what will happen is that we just have to flip that acceleration and apply a pseudo force, right? This pseudo force will be small m into a, right? The mass of this block into a. Okay. Now other forces on this block, one is the normal force perpendicular to the inclined, one is mg in the downward direction, right? And this angle will be also theta, right? This angle between the vertical and the normal reaction will be same as the angle of inclination. Okay, so we can resolve this n now. So along theta will be n cos theta, and opposite to theta will be n sin theta. Okay, so we broke that n into components. Now you can see that since it is in equilibrium now, n cos theta will be equal to mg. So n cos theta equals mg and n sin theta equals a ma. Okay, so you can just divide that. So what I'll do is sin theta by cos theta I'll get. So this is tan theta. Tan theta will be a by g. A by g, right? So g tan theta equals a. Is that option? Yes. So option B is the correct choice. Okay, so very basic, right? Apply pseudo force, then free body diagram, and then just apply the condition for equilibrium. Okay, in question 9 we have this container and a lady in that container. So that lady is making certain observation. So the first observation that she makes is that the acceleration of any object in this container is 10 meters per second square. Okay, and secondly she makes an experiment in which she ties a block 1 kg, mass 1 kg, to the top or the ceiling of that container. Okay, and that block comes to equilibrium. So you have to find the tension in the string. Again, same type of logic over there. Okay, so by the first observation you should make out that, see, there is no force on that object, right? A random object in that container, there is no force on that object, but still it has acceleration. No force but acceleration, which means Newton's law is not held, which means this frame is non-inertial. Okay, this frame is non-inertial. That was something that you should make out from her first observation. Okay, and now acceleration is 10, so this also has acceleration 10. It will be in this direction. Okay, how did I decide the direction? Because I know I am going to flip this acceleration and give it to this one, right, this block, so it should go back. So that's how I declared the direction. Okay, now let's draw the FBD of that block. So mg or 1g in the downward direction, t. Okay, now this angle with respect to the vertical will be theta. Okay, and now have I missed something? Yes, pseudo force, right? So you have to just flip that acceleration and give it to this block. So 1 kg into a. Okay, so now let's resolve this first. So you'll have t sin theta, t cos theta, and g over here, a over here, and t sin theta. Okay, so t cos theta is equals to g, so is equal to 10, and t sin theta is also equals to 10. You can see that tan theta will be equal to 1, so that theta is 1, theta is 45. Okay, theta is 45 degrees. Okay, so what do you have to find? You have to find tension. So how will you do that? Any equation you can use. Let's use this one. So t by cos of 45, 1 by root 2, okay, is equal to 10. So tension will be 10 root 2. 10 root 2. That is the correct choice. Okay, so this was the only point that you should catch, that you should grasp from the lady's observation. Okay, this was a very old question, 2005. Okay, over to the next question now. Question 10 from BITSAT 2010. Now in this question you have a spring and two mass m1 m2 attached to its either end. In the first case you are compressing that, okay, you are compressing and holding it. In the second case, when you release it, the spring pushes both of the mass with equal force. Okay, both of the mass with equal force. So first one, m1 moves with velocity v1, m2 moves with velocity v2. m1 m2 are masses, v1 v2 are velocities. So you have to comment on V1 by V2. Okay, actually you can make it directly by you'll know that see, V1 is in this direction, V2 is in the other direction, so of course it should be negative. So option C, get out of the way, option A, get out of the way. Okay, and V1 by V2, you'll know that it's inversely proportional to mass, right? By the application of conservation of momentum. So D is the correct choice. Okay, let's do it for those who didn't get it. So taking this as the system, you can see that there is no external force, right? There is no external force, so momentum will be conserved. So initial momentum 0, none of them in motion, okay, will be equal to final momentum, which is m1 v1 plus m2 v2. So you can see it from here, taking this to the other side, and v1 by v2 will be nothing but m2 by m1 and negative sign. Okay, v1 by v2 is m2 by m1 negative sign. Okay, so such a simple question. Let's go to the next question now. Question 11 from 2011. Okay, so in this question you have a man walking on a platform. Man is 100 kgs, the platform is 200 kgs. The man is walking relative to platform. Okay, the velocity of man relative to platform is 30 meters per second. Okay, you have to find velocity of platform with respect to ground. Okay, so first of all we can simplify this. We can say velocity of man with respect to platform is velocity of man with respect to ground minus velocity of platform with respect to ground, right? Vmp is Vm minus Vp. Okay, so you can say that velocity of man with respect to ground will be velocity of platform with respect to ground plus 30. Okay, so this will help us. Now you can see that there are no external forces involved in the system, so you can conserve momentum. Okay, initially suppose the man was at rest, initial momentum 0, final momentum will be m1 now 100 into his velocity, velocity of man. Now let's observe everything with respect to ground. Okay, so you have to put velocity of man with respect to ground, this velocity, not this one. Okay, so velocity of man with respect to ground, which is velocity of platform with respect to ground plus 30. Okay, so far so good. And then plus this, right, 200 into velocity of the platform, so velocity of the platform with respect to ground, of course. Now you can solve that. So velocity of 100 into velocity of platform 200, so 300 into velocity of platform into platform with respect to ground, plus this will be 3000. Okay, and this is 0 over here. You can see that velocity of platform with respect to ground will be minus 3000 upon 300, that will be 10. Okay, so 10 is the correct answer. Okay, so only the relative concept was involved in this question. Okay, so in laws of motion you might see composition among topics, okay, within the chapter itself and among other chapters also. Okay, the chapters, the concepts from other chapters can be mixed with this chapter. That is the speciality of this chapter. Let's move to the next question now. Okay, question 12 over here, it's from BITSAT 2010. Okay, actually my marker ran out and I had to wait until I purchased this one. Also, as I am filming this video today, my internet connection is down, so I hope the issue is resolved soon. Okay, so that was the reason why this video is delayed. Okay, anyways, let's come to the question. In this question you have an inclined plane which is inclined at an angle of 30 degrees. This inclined surface has coefficient of friction 0.2. Okay, you can see two blocks connected by string over a pulley. Okay, so m1 has mass 10 kgs. You are supposed to find the mass of block 2, which is m2. You are supposed to find the value of m2. It is also given that this system moves with a constant velocity. This block moves down the incline with some constant velocity. Okay, so the major catch point is over here. The system moves with constant velocity. Okay, so what you can conclude from here is that the system is in equilibrium. How can you say that? See, velocity is constant, no acceleration. Acceleration 0, net force 0, right? You can also see it by the first law of motion, law of inertia, that since the system is moving with a constant velocity, external force is 0, internal forces are balanced. Okay, so all what we need to do is just balance the forces, right? Now let's do that. Let's draw the FBD first. Let's draw it for M2 first. So we have our M2 over here. Okay, now you can see that M2 will have M2G, its weight in the downward direction, which will be balanced by the tension, right? Forces are balanced. Okay, now coming to M1, let's draw its FBD. T due to the string, also it will have some friction, right? Mu n in the backward direction, since it's moving down the incline, friction opposites relative motion. Okay, and it will have normal reaction from the incline. Also its weight will be in the downward direction, right? Vertically downward direction. I'm just going to resolve it directly. So along the incline you have m1g sin theta. Sin 30 will be half. Okay, and perpendicular to incline you'll have m1g cos theta, which will be root 3 by 2. Okay, so all what we need to do is just balance the forces, right? So m1g, first of all, n will be equal to m1g root 3 by 2. This is the normal reaction. These forces are balanced. Okay, let's balance this and this now. So t plus mu n will be equal to m1g by 2. Okay, so basically you can substitute all the values here, value of t from here, n from here. Okay, so t is m2g plus mu n. So mu and n is m1g root 3 by 2 m1g by 2. You can cancel g throughout. Okay, and now let's solve it for m2. Okay, we want m2. So m1 by 2, 10 by 2, 5, minus this will go on the other side. Okay, so you have mu, which is 0.2 into m1 10 by 2, okay, into root 3 also you have. Now an approximation was given in the question, I forgot to mention this. Take root 3 as 1.7. okay, just an approximation. Okay, so you can see that this will be 2 and this can cancel out. Okay, so 5 minus root 3, that will be our answer. 5 minus 1.7, that will be 5 minus 1.7, that will be 3.33, 3.3. okay, 3.3 kg, right? So 3.3 kg, that is our answer. Okay, so based on equilibrium, right? The question was based on equilibrium. Let's move to the next question now. Question 13 over here, it's an old BITSAT question. Okay, in this you have a composition of relative motion along with your constraint motion. Okay, so in this question you have a lift which is moving up with a speed of 2 meters per second. Now in the lift you have a block attached to a rod. This rod is first of all winding up that string, okay, coiling it down. Okay, with a speed of 2 meters per second. Also that rod is now itself going down. Okay, rod is going down with a velocity of 2 meters per second. Now you are supposed to comment what is the velocity of B as seen by ground. Okay, as seen by ground. From ground, what is the velocity of B? Okay, so quite a simple question if you can imagine it. Okay, so you can see that first of all that rod is winding up the string. Okay, winding up that string. So with a speed of 2 meters per second. Also it's going down, right? So 2 meters per second winding up plus 2 meters per second going down. So those two velocities are in the same direction, right? 2 meters per second winding up, it's winding up, and 2 meters per second in the downward direction. So those two velocities will add up. Okay, let's first watch it relative to the lift. Okay, let's go into the lift and watch what is the velocity of B. So these two velocities will add up. Okay, so these two velocities add up to 4. So 4 in the downward direction on the other hand. So here it will be reflected as, on B we'll see the velocity 4 in the upward direction. Okay, we are into the frame of the lift, we are into the lift. Okay, so 4 in that direction, downward direction, will be reflected as 4 in the upward direction. Constant motion, right? They will move with same velocity. Okay, so relative to the lift, the velocity of B is 4 in the upward direction, right? Quite simple. Now let's come to ground. When we come to ground, we see that the lift itself has a velocity in the upward direction. So now velocity of B was 4 meters per second. Remember that, okay? And 2 is the velocity of lift in the upward direction. Now again, this 2 will add up. When we see it from ground, this 2 will add up. Okay? So that velocity will be 6 meters per second, and which is none of the above. Okay, I hope the idea of imagination was clear. We did this without touching the board. Okay, I'll do it by the formula too. Okay, for those who didn't get it. First of all, let's go into the lift again. So this idea, I hope this idea is clear. Winding up plus going down. That rod is going down. So this two velocities add, that is 4. So this is going down with 4. So that will come up with 4. Okay, so velocity of B with respect to lift, L is lift, will be 4, right? As seen by lift, the velocity of the block B is 4. When we go into the frame of lift, the velocity is 4. 4 in the upward direction. Let's take upward direction to be positive. This can be splitted as velocity of B minus velocity of L. VBL is VB minus VL with respect to ground, with respect to ground. Okay, so you can simply see that velocity of B with respect to ground is nothing but 4 plus velocity of lift with respect to ground. When you see the lift with respect to ground, that will add up, right? Just as I said, 4 plus 2, 4 plus 2, and that will be 6. Okay, so you could do this question by pure imagination, none of the above, and which is 6. Okay, so composition among the topics, can you see that? So let's move to the next question now. Question 14 over here, it's from BITSAT 2011. Okay, now this type of questions are very common. You might have seen them in your reference books as well. Okay, so let's jump into it. So you have 3 blocks over here, one with mass 10 kg, second one with 6 kg, third one with 4 kg. Okay, they are tied by strings. Okay, 1 and 2. Now the last one among them is pulled with a force of 40 newtons. Okay, the 4 kg one is pulled with a force of 40 newtons. You are supposed to report the value of T2. So in this case, the first thing that you should do, you will know it, is find the acceleration. All 3 of them will move with the same acceleration. Okay, so let's find the acceleration. So basic easy way of finding acceleration is A is equal to F net upon M total, right? The net force upon the total mass. Now you can see that this forces doesn't really matter, right? Because they are internal forces, they will cancel out. The net external force is just 40 newtons. Okay, so the force is 40 newtons, and the total of these 3 masses, 10 plus 6 plus 4, which is 20. So you get the acceleration to be 2 meters per second square. Okay, so let's draw the FBD of the second one since we want T2. So this is M2. Okay, M2. Let's draw its FBD. So you have T2 in this direction and you have T1 in this direction. Okay, there is no vertical motion, so mg has cancelled and okay, let's not consider that. So you can write the equation of motion for this, right? This it's moving in that direction, right? Direction of the force. So you can say that it's moving in the direction of T2. So you can say that net force is equal to mass into acceleration. So T2 minus T1, net force is equal to mass m2, which is 6, into acceleration. Acceleration, all 3 of them have the same acceleration. That is why we found the acceleration first. Okay, so T2 minus T1 will be 2L. Right, now one more equation we want, we can get it from here. This will be the simplest one. So T1, you can simply see that T1 is moving this block, right? T1 will be the force on this block. So T1 is mass 10 into acceleration 2. Okay, so that is 20. So T1 has a value 20. So you can see that T2 will be naturally 32. Okay, so again a simple question, D is the correct choice. Over to the next question. Question 15 over here, it's an old BITSAT question from 2009. Okay, just try to note the difference between this question and all the previous questions that we discussed today. Okay, so in this question you have a block of mass m which is attached to a string. Okay, that a string is pulled with a force of 2 mg. It exerts some tension on that block. Now you are supposed to report the value of tension. So the only difference that you can see in this case is that this string has some mass too. It is a massive string. In the previous cases, in the previous questions that we discussed today, the string was massless. It had zero mass. In this case, our string has some mass, which is m by 2. Okay. So tension will differ, right? Tension will differ at every point. In a massive string, tension differs at every point. Okay, in massless string the tension is uniform. Okay, so if this was a massless string, then whatever force you exert 2 mg, the same amount of tension would have been reflected here, right? T would have been equal to 2 mg if it was a massless string, but now it is not a massless string. Now you might have your own ways of doing this question. Go ahead and do it. Okay, you might know to find the tension in a massive string, but I'm going to do it in a different way. Okay, I'm just going to break this question like the previous question, in the format of previous question. Okay, so I have this block of mass m. I'll keep that intact. What I will do is I'll just attach this with a massless string to another block which has mass m by 2. Actually what I did was just replace this string with another block of mass m2, and I placed just to connect them, they are connected, right? Just to connect them I placed a massless string. Okay, so this system is very analogous to this. Okay, and of course this block will be pulled with that force, right? 2 mg. Okay, so this system is analogous to this. Solving this will get you the answer. Okay, you can find T. Now this question becomes equivalent to the previous question. You just have to find that T. So let's write the equations. Let's draw the FBD first. So for m by 2 you have 2 mg and T in this direction. Okay, and for m, this is m by 2, right? And for m you just have T in the forward direction. Okay, so T equals ma. Okay, each of them will have the same acceleration. Now coming to this one, T minus 2 mg minus T, 2 mg minus T will be m by 2 into a. Net force is equal to, net force is 2 mg minus T is equal to mass into acceleration. Okay, now we can just add this to equations. Okay, so what will we get? So this T and this T will get cancelled. So 2 mg will be equal to ma plus ma by 2. So ma plus half ma, which is 3 by 2 ma. Okay, so m and m will get cancelled. A will be equal to 4 mg 4g by 3. Okay, so A is equal to 4g by 3. So we can just substitute it over here and get the tension. So the tension will be 4 mg by 3, right? 4 mg by 3. In place of A, I just put that value. Okay, so T is 4 mg by 3. Okay, so quite easy this way, right? So let's move to the next question now. So question 16 over here, it's from BITSAT 2018. Okay, so in this question you have a cup. In this question they have referred to this as a big cup of radius 3r. Okay, radius 3r, this is a big cup. In that cup you have two spheres. Okay, so those two spheres are in contact with the cup as well as among themselves. So this system, this entire system is in equilibrium. Those two of those spheres have radius r each. Okay, now you are supposed to find the ratio of n1 by n2. n1 is the normal force between the cup and any one of the sphere. Okay, normal force between cup and any one of the sphere. Okay, and n2 is the ratio, is the normal reaction between the two spheres. Now those two spheres are in contact, so they will exert a normal force on each other. Okay, so n2 is the normal force between the two spheres. Okay, so how will you do this? Okay, so the first thought that should come to your mind, since it is stated that the system is in equilibrium, will be drawing a free body diagram, right? So let's draw a free body diagram for this sphere. Okay, mg in the downward direction, let m be the mass of the sphere. Okay, and you'll have n1, okay, through the center, right? Here you'll have n1 due to this surface, right? Due to the cup. Okay, due to the cup, you'll have a normal reaction perpendicular to the surface. Okay, perpendicular to the surface n1. Okay, now due to this sphere also, you'll have some normal reaction, right? And that will be nothing but the normal reaction between two spheres, that will be n2, right? This is due to the cup, so this is n1, this is n1, and that will be due to the sphere. This sphere on the other sphere, that will be n2. Okay, between two spheres is n2. Okay, now you have to just resolve this. Okay, resolve that n1. Okay, so what is that angle? Let's consider, first of all, you have to use a little bit of symmetry in this question. Okay, so you can see that this distance will be r, right? This distance will be also r, right? Radius, and this remaining distance will be 2r, remaining distance will be 2r. So this is an isosceles triangle. So once I draw the altitude, it is also the median. Okay, it will pass through this point. Okay, so the altitude or the median will pass through this point. Okay, now let's consider this angle to be theta. Okay, so you can see that this angle over here, which is nothing but the angle between n1 and this vertical line, n1 and the vertical line will be theta, right? And these are alternate angles, right? So this will be theta 2. So you have to just resolve it. So n1 cos theta adjacent to theta, n1 cos theta, and opposite to theta, n1 sin theta. Okay, and since the system is in, now this is resolved, since the system is in equilibrium, just equate them, right? Just balance the forces. So n1 sin theta will be equal to what is that? N1 sin theta will be equal to n2. N2 will be n1, and the second thing will be n1 cos theta will be equal to mg. Okay, so you have to find n1 by n2, which is nothing but 1 upon sin theta or cosec theta. Can we find it by the triangle? So let's isolate that triangle over here. Okay, so theta over there, and we want to find cosec theta, right? So this distance is 2r, right? This distance is 2r, as I said, and this distance we don't know. This distance is r. So we have to find cosec theta from there. So basically, what will be that? That will be hypotenuse upon the opposite side. So that will be 2. Okay, so n1 by n2 is nothing but 2. Okay, so had to do with the symmetry, that's why it was pushed into the moderate level. Okay, let's move to the next question. So the discussion on laws of motion is incomplete without discussing block over block type questions, right? So here it is. Actually, this is your homework problem, but I'm going to leave you at a crossroad. Okay, so in this question you have two blocks, one of mass 10 kg, other one of mass 2 kg. There is no friction between block 1 of 10 kg and the ground. Okay, but there is friction between the two blocks. Okay, so that has a mu value, coefficient of friction is 1 by 3. Okay, so you have to find the maximum force at which both of the blocks will move together, right? The maximum force, this is F max, the maximum force at which both of the blocks will move together. Okay, so this is quite a standard question, right? So we have a well-defined approach for it. Okay, so let's do it. So when this force will be the maximum force, then the driving force for the second block, for the block on top, will be the limiting friction, right? When this is the maximum force for which both of them are moving together, the driving force for the block on top will be the limiting friction. So let's find the limiting friction. It will be mu s, or 1 by 3, mu value is the same. So mu into mg, right? N will be mg, and in this case will be mg. So m, which is 2 for this block, right? Excuse me. So n will be mg, right? So 2 into g. So that will give us 20 by 3. Okay. So the limiting friction value is 20 by 3. Now we can find the maximum acceleration. Okay, maximum acceleration from this value. What is the maximum acceleration of that block? Okay, the block on top. Okay, block for the block of 2 kg block. Okay, maximum acceleration of the 2 kg block will be nothing but the force, the net force divided by its mass, right? Net force is nothing but the only force acting on the block above is the limiting friction, right? In our case, it's the limiting friction divided by the mass. So mass is 2 kgs, so that will be 10 by 3. Okay, now let's substitute that acceleration. Since both of them move together, both will have the same acceleration. So I'm just drawing the FBD of the second block, the block underneath. So F max minus FL, right? In the opposite direction, there will be some limiting friction due to the block on top. It is opposing relative motion. So you can write F net equals ma. So F max minus FL equals mass into acceleration. Since both of them are moving together, both will have the same acceleration. That will be 10 by 3. So F max will be nothing but 100 by 3 plus FL. FL is 20 by 3. So that is 120 by 3, which is 40. Okay, so you might be in a hurry now and mark this as the correct choice, and there you go, -1. Okay, so this 40 is not the correct answer. The correct answer is 30. How is that the correct answer? That is something which you are supposed to tell me in the comment section. So the correct answer will receive a heart from me. How is the answer not 40 and how is the answer 30? Okay, a few general observations that I could make from the previous year questions. So I have mentioned here the important topics. Again, keep in mind that these are not the only important topics. These are just the topics in focus. Okay, the other topics are important as well. Okay, so you have questions being asked from impulse. Here is the weightage. Okay, questions being asked from impulse. Block over block are also favorites of BITSAT. They are asked in a scattered way over the years. Okay, here and there. Momentum, you may be asked questions on momentum conservation, impulse momentum theorem, right? Conceptual questions are asked. Your concepts are put to test. Okay, based on laws of motion, maybe the theory type. Okay, theory and concepts. Okay, then circular motion, not many questions are asked, but I'll insist that you should focus on circular motion because it is a source of your easy to moderate category type questions, right, which are suitable for BITSAT. So focus on circular motion as well. Now the most appeared questions in BITSAT are the ones from the topic equilibrium. You might have noted this today as well, right? So the most commonly asked questions are from equilibrium. Okay, so keep a good hold on all these topics. That will make you a pro at laws of motion as far as your BITSAT is concerned. Okay. Again, note that a fine line cannot be drawn between the topics. One topic can be mixed with another. Two different concepts can be mixed together. Okay, this is very common to happen in laws of motion. Okay, not just two topics from the same chapter. You might have composition from laws of motion and some other chapters. Okay, so laws of motion is very famous for that. Okay, so the discussion on laws of motion does not end over here. So with that being said, let's wrap up for today's class. I hope you enjoyed it. I'll see you soon in the next class. Do follow the word series which is going on my Instagram. Okay, that will help you boost your score in the English section of the paper. Links in the description box below. Smash like, subscribe. Keep enjoying physics.